Okay, so wow, this is really weird.
Yeah, I know.
Okay, so whatever. Like this is like really squiggly, but what can I do? Okay. Okay, so there's two guys pulling on a pulley. This guy is 70 kilograms. This guy is 60 kilograms. This is student A. This is Alfred, and that's Benjamin. Oh, wow, it's recording the whole time. That's so annoying. All right, on the dots, draw the label the free body diagram showing the forces on the students. All right, so for Alfie, I'm going to do it in green. I'll just use him. So we got, okay, that was supposed to be green. Okay, so that's FG, right? This is FN, and then this is tension. Okay, and then for Benny over here, we got FG, and we got tension going up. Okay, so we know for student A, sum of the forces is equal to 0, right? Because nobody's accelerating. You just stand there. So then we say Fn plus T equals Fg. And I'm going to say this is F1g and that's F2g. Okay? So then that's for him. Then for B, the sum of the forces are also 0. God, that's so annoying. T is equal to F2g. Now, I can substitute that in there. So I get Fn is equal to F1g minus F2g. And so that's going to equal M1, or let me, G times M1 minus M2. And so that's like 98 newtons or something. Part B says, calculate the magnitude of the force. Oh, just kidding. That was part B. This would be part C. Student A now climbs up the rope at a constant. So the acceleration of B is 0.25 meters per second squared. That's completely illegible. Calculate the tension in the cable, or tension in the rope while student B is accelerating. So we take the same statement for student B. We say sum of the forces is equal to, but now can we say 0? No, it's MA, right? And we know that it's T minus F2G equals MA. So T has to be equal to MA plus M2G. So it's like M2A plus MA. Does that make sense? 3? Okay. So that's 603 newtons. Okay. For D, is A pulled up off the floor? Well, first of all, A, what is keeping A on the floor? Gravity. And how much is the value of the gravity keeping A on the floor? Right? It's around 700 newtons. Does that make sense? So, is this tension enough to make A lift off the floor? No. Okay, so the answer is no, and the justification is that T okay, is less than m1g. Okay, and then part E says, with what minimum acceleration must student B climb up the rope to lift student A upward off the floor? So for this one, we can play straightforward statement that involved everything. Oh, whoops, I guess I should. Us to get A to lift up off the floor, then we need Fn to be 0. Because if Fn between you and your chair is 0, what are you doing right now? You're floating. Does that make sense? So the minimum that we need to do is to get this guy to float is somehow lift him up off the floor. So we're going to use this logic like we did before, but we have to use the 2 correct for statements. And the for statement again for A, which I'll put in yellow so you can see this, was something like, what am I going to say? T plus F sub n is equal to m1g. And then the other one was, it's this one right here. It's T minus m2g equals m2a. So then here, T becomes m2 times a plus g. Now, you know what? I'm not going to do that. Self. That's what we're looking at. Plus m2a. And then over here, oh, look at that. I said I was going to do one in green and one. Here, let me try this. See if this works. Green. Ah, crap. No. C'est la vie. That's the bell. All right, but do you see what we're doing? You just do these two. Now, set these two equal to each other, right? Solve this for t, solve this for t, set them equal to each other, solve for a. That's it. Okay, so t over here is equal to mg. Yeah, t is equal to mg. Because remember we said if he lifts off the ground, Fn goes to 0.
Oh.
See that?
Okay, yeah.
Yeah. So then what we get is m1g is equal to m2g plus m2a. And now we can solve a is equal to m1g minus m2g all over m2.
Yeah.
So